Hello friends, welcome to the new session 14 on isometric projections where we are doing different pyramids, different prisms, different frustums and all that. We'll start with the combinations also if possible in this session. Okay, so here the first problem is it's a triangular prism of size 100 and height 20 is resting on its triangular base on HP. Draw the isometric view or projection of this triangular prism in this position. Okay, it's a triangular prism. Okay, triangular prism means the square prism will have a square base, triangular prism will have a triangular base. Okay, the first thing is make 100 mm 1 to 2 is 100. Okay, then 2 to 3 is 100, 3 to 1 is 100. First draw triangle of sides 100. Okay, immediately enclose it in PQRS, which is the principal solid. Okay, enclose it in principal solid PQRS. Okay, then once you enclose it in PQRS, 1 to 2 of the triangular prism is only isometric, but 2 to 3 and 3 to 1 are non-isometric edges which have to be vanished. Okay, now once you get this will be 100 because this 1 to 2 is 100, but this will be 87 only. Okay, now to draw it in this in isometric, what you do first, we are concentrating on isometric view only. Take this 100. Okay, this RS 100, RQ 87 you take. Okay, RS 100, RQ 87. Draw this line parallel to this. Draw this line parallel to that. In that way you get P. Okay, then as you know, one of the triangular prism is mixed with P, that is 1 here only. 2 of the triangular prism is mixed with Q, is 2 here only. 3 is between S and R, you take in between this 3. Okay, height is 20, that is why from these PQRS you go up by height 20 here, 20 here, 20 here, 20 here. Okay, in that way get the top surface also. Again, as you know here, 1 is mixed with P, 2 is mixed with Q, 3 is mixed with 3. Sorry, 3 is mixed, 3 is in between Q, R and S. 3 is in between R and S. Now, this is the triangular prism. The skeletal part of the work is over. Now, darkening. Now, as I have been telling you continuously, darkening procedure is always from the top surface, then left surface and right surface should be darkened. For this, there is only one single solid. First top surface, you darken it. 1, 2, 3. Then, once you do that, left surface and right surface should be darkened. That is why I'll go. This is the left surface. Right surface anyway you can't see. In that way, this left surface you darken it. Okay. The right surface is not there because this is the left surface and right surface common it is. Okay. This left surface and the right surface, this 3 3 is referring to the right surface, one vertical edge. Back edge and all that you can't see. Then 1 to 3 you write. 1 to 3 you write as a 1 to 3 and this is 1 to 3 is invisible edge which you make it light. That means this becomes the isometric view of a triangular prism and this is how you go about in doing. Okay, and if you take the entire thing and multiply by 0.816 scale factor, it becomes isometric projection. Now a tetrahedron, you see here tetrahedron, for some universities they deliberately give whether you know the concept of tetrahedron or not. Tetrahedron of size 45. Tetrahedron, you should know that it's a triangular pyramid only with all edges of the tetrahedron measuring the same length. Okay, it is like a triangular pyramid. Triangular pyramid, base edges are same, slant edges are different. But in tetrahedron, base edges are also same, slant edges are also same. That is why first thing what you have to do is you draw tetrahedron, that is 45 mm triangle you draw. This is 45, 2 to 3 45, 3 to 1 45. Draw 3x. Okay, 3x parallel to this. Okay, then you see the corresponding front view also you do. This is 1 2 3, 2 dash bracket 1 dash. This is O dash apex. Okay, now as you know here, this edge, this slant edge, you see here, actually This is on slant edge for this. This is on slant edge, and this is on slant edge for triangular pyramid. But here it is a tetrahedron. Okay, but since it is tetrahedron, this length is parallel to VP, correct? Huh? That means this length in the front view should be seen in its true length. That is why this you take it as 45 only, because this is seen in its true length in the front view. Okay, this is 45, C3 or O3 or whatever you call it. This is parallel to VP, hence this will be seen in its true length. That is why 3 dash as center, 45 as radius, cut here. In that way, complete this. Now you have top view and front view of a tetrahedron, which has to be written carefully. Now this is the height of tetrahedron X. Height of tetrahedron 37. In that way, the height of the tetrahedron has to be found out in order to complete this. Okay, this is the height of the tetrahedron. Okay, now you see here, once you get the top view, front view, enclose it in PQRS as usual. Okay, that is a principal solid and all that. This will be 39. This will be 45 anyway. Okay, and you see here, you take the perpendicular bisector of this. 3x is already the perpendicular for PQ. For 2, 3, you make the perpendicular. You get C, center of gravity point. Okay, center. Then you measure this distance also. That will be 26. Now you see here. What you do, now I have started from QR. QR is 39. QP is 45 you take. You don't have, you can do this way also. You can take this as RQ, this as RS, nothing, no problem at all. Okay, now I have taken this way. PQ, for better visibility, I have taken this. PQ 45, QR 39, actual only you take. Okay, then draw this line parallel to this line parallel to this. In that way you get S. Now as you see here, 1 is with P. Okay, 1 is with P. 2 is with Q. 2 is with Q. And 3 it is in between R and S. Okay, in between R and S. It is 3 here. Okay. In that way, first you join this light line. Join this by light line. Then get the center of gravity. 3 to C you cut. This anyway 3x is a line parallel to RQ or SP. Hence it is isometric line only. Okay. Hence 3C you can directly cut. 3C you cut 26 on this. 3C you cut 26 on this. Once you get 26 as C point, from C you go up. From C you go up to this. This is anyway isometric, but this is non-isometric. But this is isometric. Okay, this height is isometric always. This X is 37, no? That is why C to O you take 37. Okay, once you get 37, more or less the skeletal part of this work is over. Then go along the outer boundary. Go along the outer boundary O to 1, 1 to 2, 2 to 3, 3 to O. Okay, in that way, this solid which is having 6 edges. Okay, triangular base, you see here, triangular base 3, O to 2, O to 1, 2 slant edges merging each other, and O3. In that way, 6 edges are there. Now, if you see 1, 2, 3, okay, when you have this, you see here, since it's a triangular pyramid, that is tetrahedron, like same as a triangular pyramid, you have to darkening procedure. But darkening procedure is you have to darken the top surface, you have to darken the left surface, right surface. But since the top surface is a point, don't worry about that. Left surface you see, left surface edge and right surface edge you concentrate. Now we have only left is O to 2, which is the left surface edge. In that way, left surface is this, right surface is this. You can actually stop at that. Okay, this is the isometric view. This will be the isometric view of a tetrahedron. If you want the isometric projection, take this entire thing, multiply by 0.816, and you will get the isometric projection of the previous isometric view what I have drawn. Okay, in that way this problem gets completed. Now you see here, there is a problem here. A sphere of diameter, okay, 30 rests centrally on a frustum of square pyramid. frustum of hexagonal pyramid. See here, this I've told you, this is called the orthographic projection, which we'll be doing in the next chapter and all that. You should know clearly, as soon as you look at the front view, top view, we have done in the past, in the earlier sessions, I've already introduced you with orthographic projections. You have to be careful here. Look at the front view, top view of the two solid. First, base solid. Base solid, if you see here, hexagon, another hexagon, okay, in the top. That means one bottom hexagon is 30, top hexagon is 18, and height is 50. Okay, height is 50. That means looking at this, you immediately know it is a frustum of hexagonal pyramid, bottom hexagon 30, top hexagon 18, and height 50. See here, bottom, it is resting on bottom hexagonal surface on HP. Okay, and over this you have a cylinder of diameter 30. Sphere of diameter 30. And you know very well, spheres will not reduce the diameter, but C to C you have to take 15 iso, because C is a combined axis which is isometric, which will reduce in its length. C to C you have to take carefully. Okay, that is iso 15. Okay, now this has already been done. You please look to my earlier sessions where I have done the how to do the frustum of hexagonal pyramid for the same dimension. Frustum of hexagonal pyramid, how to do, I have already done. Okay, you please look to that. Okay, now you see here, this is frustum of hexagonal pyramid. You draw, and sphere, it is actual diameter only you draw because it won't reduce in the diameter. Okay. Now this has been done already. I have just introduced. Okay. Now once you get that, from here C to C you take 15 iso. C to C you take 15 iso because the common axis will reduce in its length. C to C you take 15 iso. Once you get this 15 iso, okay, then this sphere will not reduce in diameter in isometric. You have C for this also. Move this sphere with respect to this C. Okay, move this without copy and place it at this C. Okay, in that way you place it here. Then R is equal to true diameter 30 only. R is equal to, it is true diameter, this R is equal to true radius, okay, 15 or diameter 30. Okay, now once you do this, you have to concentrate on the visibility part. Visibility part, as I told you, it's always from the top solid, top surface. But since it's a sphere, it is only top solid is only a sphere. It just directly darken the circle of diameter 30. Okay. Now come to the bottom solid. Bottom solid is frustum of hexagonal pyramid. In that, concentrate on the top surface first. When you concentrate on the top surface, this back portion and all that cannot be seen. Hence you make it light. Okay. Hence you make it light. Okay. Then once you do this, this will be the isometric projection of the two solids one over the other. The top solid is a sphere of diameter 30 and the bottom solid is a frustum of hexagonal pyramid. Now you see here, if in the later section, in the next section, they'll give you this type of problem. They'll give the isometric projection. Okay, like this, they'll give this here 1, 2, 3, 6, 4, 5 and all that. If I name it in that way. Okay, if I do this, when you're looking from here, how the front view and top view appears. See here, this is the top surface, this is the bottom surface, height is 50, okay, this is 30 hexagon, this is 18 hexagon. In that way, these are all the slant edges, okay. In that way, you complete the bottom solid, okay. Then once you complete the bottom solid, the top solid, if you do, it is a circle in the front view, circle in the top view also because it is a sphere. Okay. In that way, you are completing the frustum of hexagonal, in that way you are completing two solids, one above the other. One is a sphere, one is a frustum of hexagonal pyramid. This is the isometric projection. You can actually stop at this. Okay. For the next chapter, this will be required. When you are looking from here, how it appears in the front view has to be written, and this is how it appears in the front view. Okay, this at this stage we will come to the end of session 14. Okay, We'll continue this in session 15. Thank you very much for watching.